2003, and this paper is really highlighting sort of, I guess at that point, 8 years of success in this domain. In about 2005, we sat down and we took a look at this cataloging and archiving service, and we decided that what we really needed to do in order to handle larger scale data volumes, the challenges that I was talking about, is refactor this service. And we did that. We looked at a couple of these different core capabilities, and we described them in this way, that basically file management, workflow management, and resource management should be separate from one another. We modularized in that way. In addition, we sort of conceived these as core services around which one could build frameworks that would utilize the services and orchestrate them in interesting ways. And so a couple of examples of that are what we called our crawler framework, that was really file and discovery, product discovery based search and retrieval, and then our what we call PGE framework, which is basically science generation capabilities. And the timeline for this is basically what I described. We started funding in 1998. In 2000, we deployed this for the National Cancer Institute, which is a United States government venture, part of the National Institute of Health in the States, to help them do cancer detection in bioinformatics. In 2002, we infused these components into an existing mission as a start and a way to gain traction and show the feasibility of this new way of structuring the software. And we built this into a mission called Sea Winds. It measures sea surface, winds, velocities, and temperatures. One of the interesting things to note about that was that it was designed for 2 years of operation. And the software has been stable enough, and the spacecraft has actually been stable enough, that we're still operating today. And so this is actually the primary means of measuring and detecting hurricane tracks. So it's actually a vital piece of international warning system for hurricanes. In 2005, this is when we decided to refactor this. It was really, the impetus was really two projects that we had coming up. The first was OCO, which is called the Orbiting Carbon Observatory, and that's a satellite system that was designed to detect and measure carbon dioxide ebbs and flows in basic carbon footprints. And then the second was MPP Sounder P. You'll forgive me, the acronyms go crazy on this one because it's a joint venture between 3 different government agencies. So the N is actually its own acronym, and it's a nested mess. And actually, there's disputes about what things stand for anyway. So we'll just say it's the next generation of weather satellites. So this will be the system that we use to capture that data for long-term climatological records. And what are we supporting today? Well, actually, this list has grown a lot, and that's part of why we're looking at expanding to open source. I'll get into that in a minute, but the list has grown a lot, and that's because of the success of these early missions. So today we're supporting 2 more missions that are coming up. We're going to do soil moisture and something called Destiny, which is basically crustal deformations of the Earth's surface. So earthquakes, and also it's got other structural and dynamic properties. Yeah. Oh, so. And in addition, we're also exploring other projects now that we didn't necessarily envision this framework to be initially applicable to. As I said, we had one sort of outlier very early, and that was this bioinformatics project, but more systems have come along in that vein. We're supporting California's water resource management system now. So we're studying water table dynamics, and we're building basically decision-making frameworks for how to allocate resources for the state of California in terms of water usage. I don't know, since we're kind of far from there. We're in California in about 10 years of drought now, so I guess 8 years of drought. So this is an important thing. Additionally, I just started a project that we're calling the Thermal Properties Database, which is going to collect all the information that we've ever gathered on heat shield characteristics in order to reduce the costs of sending spacecraft into orbit by, basically gathering up all that we've learned about, burning things up. We're studying a number of phenomena via airborne instruments instead of spaceborne instruments, and we're bringing that in-house and putting that under the umbrella of sort of an initiative to study the bursting capabilities of different cloud technologies. So, Amazon in the back for help with that. And we've got more work in bioinformatics as well as part of a pediatric care system that we're developing. So the applications of basic data and computational grid systems are really far-ranging. And what we've found is that we've grown a lot of internal support and also external adoption by building this successful framework. And one of the things that we're going to be interested in is building up those use cases through external partnerships. So I promised that in the second half of this talk, I would focus on some interesting transitions that we've had with this software. The first one is really a transition to using more open source. In 1999, when we developed the first, 1998, when we developed the first version of this platform, it was built entirely in-house, and it was all closed. And the first refactoring that we did in 2005 was really a push toward moving in this direction, using open source technologies, and also contributing to open source in turn. The second transition that I want to talk about is when we actually moved to becoming an open source project, and how we used adoption of open source practices internally first as a stepping stone, and how that was a successful bridge for us. It's important to note that these things take time. I think that's also going to be, something that I want you guys to take away from this when we talk about transition, is that these kinds of cultural shifts are something that you really need to have not only a groundswell for, but also time to change your institution's culture or your company's culture, wherever you find yourself, to be amenable to this type of work. And it took a lot of intermediate steps. So when we started refactoring software in 2005, we really already had our foot in the door in the open source world. And that was the first sort of successful bridge that we made. And that was that two of our lead developers for this project were already involved in different open source projects and had been for a while. And so we had our own internal guides to the process, and we had some sort of internal knowledge already in place to allow us to navigate what was essentially a new world for a lot of our developers. So the team at that point in time was about 6 people, and 2 of the 3 senior developers were also open source contributors. And so that's, the logical step when we decided to refactor was to look at what was out there. When we refactored in 2005, what we saw was all of a sudden things like Lucene and Solar could help us a lot with search. And Derby was a great in-memory database for some of our smaller distributions. And things like Tomcat and Spring were helping us on the infrastructure front, the development fronts. And at the same time, we changed a lot of our build practices in 2005 to include things like Maven and continuous integration. And so So this was really the first inflection point in our timeline, was building out our own structure in such a way that it was becoming amenable to a transition to open source. And I think that's I think the having two lessons learned that I would share with everybody is having some people who are early adopters who can act as mentors and guides internally is a very important step in this process, and then also just making sure you're ready to make that transition in terms of infrastructure, in terms of how you're building your code, in terms of how you're structuring your code. These are important steps to take to ensure a successful transition. But at the same time, there was certainly a lot of culture shock at JPL. And on the technology side, we were claiming don't reinvent the wheel, especially when you're going to do it poorly. There are all sorts of examples of this floating around. I'm sure any company, but there's some pretty shocking examples of in-house database developments and things like that people were trying to do throughout the 80s and 90s at JPL, and it just didn't pan out. And so, don't reinvent the wheel was one side of this debate. But at the same time, we're talking about an organization that's very risk averse. I said that our public failures are very public. It's true. When spacecraft blow up, or you lose the data from the first walk on the moon, these things are bad from a public perspective. And so there were a couple of things that we did to mitigate this. I think there are certainly technical solutions out there, and we used a lot of them, modularity, extension points, interfaces, to isolate our core from these different open source implementations of technology. But at the same time, there are a lot of social solutions out there as well. Get people involved and actually own the open source code that you're using. And what I mean by that is don't treat it like a black box. Get involved where you can, and understand that you really need to, especially in a risk-averse environment, you really need to be able to transition away from that implementation within a well-defined timeline if the situation arises that you need to do that. And so that's how we quelled a lot of the management debate on the subject. But again, it's a long process. We're sitting at the end of it now, but it's taken 5 years. And the second transition that I want to talk about is becoming an open source project, and how we adopted some open source practices internally first, and how that helped our transition. In 2005 to 2010, we had an interesting internal dilemma as well. We grew a lot. The two projects that I was mentioning in 2005 have ballooned to 7 current projects and a lot more in the works. And we went from about 3 lead developers and a couple of ancillary developers to 12 core developers and a user group internally at JPL of about another dozen. And again, we turned to open source solutions for this. The things that helped us manage this growth were the same kinds of techniques that we saw in the open source world: mailing lists, meritocracy, and really much more controlled build and release management helped us significantly in this process. And it actually had a twofold benefit, right? Because it got our growth under control, but at the same time, it helped our transition to becoming an open source project eventually, because we had a lot of things in place, and we had, more importantly, a culture in place where our current developers already understood a lot of the philosophical underpinnings of transitioning to open source, so that we didn't actually have to proselytize this internally at all. And so in January of 2010, so this year, we entered the Apache incubator. But we had actually started this discussion in 2007. And so, there was a little over 2-year process involved, I guess two and a half, 2 3/4. And it was not a technology issue. It was actually our lawyers. One of the major challenges for us as a pseudo-government institution is that we have a lot of restrictions on how and why we share intellectual property with others. And so getting people to arrive, especially the managers and lawyers at our company, to arrive at a place where they felt comfortable distributing this work was again, a long and drawn-out process, so it takes time. And we had a number of goals with this transition, and we're still in the very early part of this, so we really have no metrics on how this is going to pan out, but certainly increasing the accessibility of the software is important to us. Creating an open forum for our external collaborators to work. So a lot of our partner institutions are universities, they're used to this kind of makeup, and they can actually contribute back to the source code for the first time. We want to build a community because we think it's important to improve quality of the software itself, but also the potential innovation that comes with more people looking at this code. But maybe the most important thing is getting more use cases, more and different use cases, because we saw that one of the major reasons for our own success was that we started looking outside of the very limited scope of earth science processing systems, and we moved toward more general data management issues, those of bioinformatics, those in general decision support systems, as opposed to very specific scientific work. And so that's going to be really important for us as well. And finally, the exposure that we get on this is pretty nice. Papers, talks like this. We have a nice bit of software. We've had it for a while, and we'd like other people to be using it and working on it. So this is just a couple of pointers. We actually haven't made a first official release yet, but we're looking to very soon. We're looking for new committers, and so that's my plug to entice anybody here. We already have a lot of subscribers on the mailing list, so we have a lot of people who are lurking, but we want people who can contribute as well. I think that's going to be important for us. And so, just to summarize with the negative 2 minutes that I'm at, JPL is an example of hopefully successful software development that's transitioned. We moved from closed in-house development to a lot of open source leveraging, and now we're moving from open source to becoming open source ourselves. Each transition involves a certain level of culture shock, and it takes a lot of time, but there are a number of steps that we took to ease this transition, and we think they're probably generally applicable lessons. So this is my sexy slide. People should get involved because you get to work on cool things. Okay, so thank you very much. Take anybody's questions. I should also thank everybody for sticking around in the last session. I know